Hello, welcome back to Sushi Live Noding. In this episode, we're gonna take a look at one Spreadshop node that I haven't used. It's called the Overlap Polygon, and let's see, have a look at the documentations. So this is Overlap Polygons, and there's this inputs description and then parameters, and also the outputs. I think the easiest is actually to just try the nodes. So you can see, you can kind of guess what it's doing. If you have two polygon mesh and you want to know where the polygons overlap, you can do it this way. So let's try that. I'm gonna use a box, and let's save it first, overlap. And I will also use a plane. So let's see, and right click, connect it to viewer draw. And this is a simple plane. We're gonna turn it into a grid. So let's make it 20 by 20. So 400 points. We're gonna center it. And with this one, we have a box. I'm gonna give a different color and just gonna resize it. Maybe give some resolution as well, 10 by 10. So we have a box and we have plane, and they are overlapping. So the next thing we want to do, let's use overlap polygons. So this should be pretty easy and intuitive to use. There's this epsilon and all triangles. Let's see what it does first. So we have the plane and we have the box, and let's actually turn this into wireframe, something like this, like kind of transparent. And let's see if we have this overlap working. So overlap polygon A, we need to pipe in the vertices from polygon A, and we are seeing something. Let's give it a different color, green. So we are seeing something. Let me change the size of the cube. So it does actually kind of generate polygon that's overlapping. Maybe with these overlap polygons, we need to turn on all triangles, or it doesn't work, or increase the epsilon. So that doesn't quite work either. Let me increase the number of polygon on the grid. And epsilon 0, resize the cube. So this seems to be very sensitive. Maybe I need to have a bit of value on the epsilon. Interesting. So it's not like what I expected. Slightly more sensitive. I kind of expected to give like a full square, but it is sort of working. Let me try, instead of using a box, let's try using a sphere. So sphere, plug this into that guy. So with the sphere, the effect is still seems to be a little bit better. I have a feeling this is because I have more points, but no, I think with the sphere it's much better, which is kind of interesting. And maybe I can try the epsilon. So instead of having the overlap based on polygon A, apparently I can also use the sphere. So this is like a different output that you can get from this guy. So with this, of course, if you if you move the plane, it's going to be more obvious. So I'm moving the plane, right? And we can see the part that's overlapping on the sphere is being generated. It's become a real like another mesh. I can bake it out, and we get that. So this can be pretty useful. Depend on what you're doing. I don't know what exactly it is for. Let's say in this, with this example, we have two objects, the plane and this deformed plane. Let's try that. So we can have a plane and exactly the same plane, but we're gonna randomize it. Let's see what we're gonna get. Randomize it in Z. So that's our plane. Let's see the output. So yeah, that's the result we are getting. It's kind of interesting. Let's actually move this to the side. So that's the result. If we also have this visualization, so that's our original plane. This is the one that's being deformed, and this is the result of the overlapping plane. Randomize the seed. Play a little bit with the Z. So maybe instead of random, if we are using noise, maybe vector noise. Use the plane, plug the result there. Okay, maybe use vector math. Just add them together. This one should go there. Maybe just do it in the z-axis. Like so. So we have the noise, and there should be a result. Maybe I need to also play with the noise value. Maybe there is nothing overlapping. Yeah, that's what I thought. Let's increase the noise. Okay, that's kind of pushing up. Maybe pushing it down should get some overlapping. No, there is no overlapping if you are doing it this way. So I need to move it down somehow. So original plane, and I'm adding them together, but I need to also move it down a little bit. So move, minus, and this one should go into this guy. Now we have overlapping noise. A little bit tricky, isn't it? Sometimes it does kind of feel a little bit tricky, but when you get the result, it's kind of nice. So that's a Perlin noise and the part that's overlapping. This actually can be really useful if you want to have like a, what do you call it, like layers of cutter, laser cutter, and you want to kind of rebuild this guy. You can have multiple of this middle part and then see which part is overlapping, and you can create an interesting pattern based on this file, save as. Maybe you can also use it for mapping and topology Perlin, noise, Voronoi. Just keep it simple. Just leave it at Perlin. So this is, of course, we can control which parts overlapping by multiplying this guy, and also by controlling this. It's almost like the effect is almost like a X-ray that's going through your body. This can be useful. Maybe you have like a monkey head and then you kind of run like a laser scan through the monkey and you're gonna get this effect. Okay, so that's a quick look at these overlap polygons. Hopefully this is very useful and you easily understand the concept. Let me know if you have anything to add or any questions, and I'll try to answer it. Thanks again for tuning in, and I'll see you next time. Bye.